Now we'll enter into the revision of the supervised learning, and this is a revision video, so we'll not get into the detail as we did get in the live session. So keep it that way only. So there are multiple supervised learning models, but today we only have to discuss few of them, like penalized regression, KNN, K nearest neighbor, SVM support vector machine, and decision tree or cart, and random forest. So without any delay, let's jump into the penalized regression. Now, penalized regression, as the name suggests, you are penalizing the regression for having more number of independent variables or number of features, more number of features. Why we are going for penalizing? Because we want the model to be parsimonious. We want that the model should have least number of feature which explain the model in the best optimum way. We don't want to increase the number of feature for a very small increase in the explanatory power of the model or R square of the model. Because if you keep on increasing the number of variable, most of the time that will lead to the problem of overfitting. We discussed already that what is the problem of overfitting in detail. Now assume your model is that through regression model you develop the model that y hat or yi is equal to b naught plus b1 x1 plus b2 x2 plus iterator. Now I want to add more variable. As you add more variable, this particular regression, this particular methodology of penalized regression will penalize the model. Now, actually, this falls under the domain of regularization. So, regularization is a concept where you penalize for more number of variables. And there are two types of regression here. One is ridge regression, which is not in our curriculum, and another is the lasso regression, which is in our curriculum. So we'll start with the concept of regression. We'll try to recap the concept of regression. In regression, what we are trying to do, we were trying to minimize the sum of squared error. We had our y, which is the actual y, and we predicted y hat. And we were trying to minimize the sum of squared error, right? We were trying to minimize the sum of squared error. And when we try to differentiate, we find the b1, b2, b3, correct? Now in lasso regression or in ridge regression, we are again minimizing the sum of squared error. So this is the equation of ridge, and this is the optimization function or objective function of lasso regression, which you are trying to minimize. So here you are trying to minimize the sum of squared error in both the cases, but you're also trying to minimize something. You're trying to minimize in the ridge lambda into the summation of square of all the coefficients. And in lasso regression, you are trying to minimize the lambda of sum of absolute values of bi. So basically, you have your b1, b2, b3 in the model. So the summation, the absolute value. So if it is negative, convert it into positive. The sum of absolute value you're trying to minimize, and there is lambdas. Lambda is called as hyperparameter. Even for the time being, let's assume the lambda is 1. Lambda is 1. When you try to minimize b1 plus b2 plus b3, what will happen? The model will try to drop or decrease the value of b1, b2, b3. The model will try to minimize the sum, and for that either it will drop one of the coefficient or it will reduce the coefficient. So for example, your earlier model is say yi is equal to 500 into 4000 x1, 3000 into x3 plus 10 into 3000 into x2 and 10 into x3. Now because of this minimization of the sum of the coefficient, what will happen? Your coefficient will fall to 5, 10, 5, 40, 30, and it may drop one of the coefficient, which is x3. You can see that the coefficient get reduced by a multiple of 100. What else can happen, or what else can happen, that if your model is y is equal to b naught plus b1 x1 plus b2 x2 plus b3 x3 plus b4 x4, it will drop x3 and x4 value, and the model will have at the end only x1 as a variable. Now, what about this hyperparameter? This lambda should be given by the model owner or the domain expert or the researcher. It can take any value between 0.0001 to say 5, 10, 1, 2, 3, 4, 5, whatever the value would be. The lambda can get any value, but understand, higher the value of lambda, more the penalizing would be there, and therefore more number of coefficient will start getting dropped from the model. So you have to keep this lambda, the hyperparameter value, such that your model should not be too simple and your model should not be too complex. So the model should be parsimonious, but at the same time it explaining the why properly. Okay. So this is all about the Lazo regression that we have to understand. We discussed about the Lazo and the ridge regression both because there is a very slight difference between the ridge regression and the Lazo regression. Okay. The another model that we have to discuss is the support vector machine. Okay. Support vector machine is used whenever there is a problem of classification. When you have to answer, your model have to answer in yes or no, or your model have to answer whether person will default or won't default, or whether your model has to answer whether something or someone will win or lose, right? So whenever the outcome is dichotomous in nature, you use the support vector machine. Now let's understand that how it works. So assume that x1 are some features and x2 are some features. And when you plotted the as in the data, these are some set of data which are triangle and these are some set of data which are circle. Now you want to differentiate between this triangle and circle with the help of a line. With the help of a line. Now this could be one of the line, this could be one of the line, or this could be one of the line. Any line you can plot to differentiate. So there could be 1,000 line that you can draw to differentiate or divide the area between the triangle and circle so that you can separate the triangle from the circle properly. Which line to select? Okay, so we'll talk about which line to select. For the timing, you selected a line. This line, the green line you selected. Now, what is the meaning of word support vector? So support vector is the nearest triangle or the nearest circle to the line, and this line is called as hyperplane or the decision boundary. To the right of this line is circle, to the left of this line is triangle. Okay, so this is a decision boundary or hyperplane which is separating the circle from the triangle. Okay, now what is support vector? The nearest point to this hyperplane is the nearest opposite points to this line is called support vector. Now what you will do, you will plot a parallel line from these support vector. So you can see for this triangle, which is the nearest triangle to this line, I plotted a parallel line to the hyperplane or the decision boundary. Okay. Now, now this D1 and D2 is the distance from the hyperplane to the line that you plotted from the support vector. What is support vector? The nearest circle or the nearest triangle to the hyperplane. Now the sum of D1 and D2 is called as margin. We just talked about that what are the different terminology we have. We have support vector as one terminology, hyperplane, decision boundary, and margin. So these are the sum of the terminology. But we haven't discussed that why you have selected this green line, why not the blue line or the white line. Okay, so the problem statement was there could be multiple line possible. Why you have selected the green line only? Why you haven't selected the blue or white line? So let's talk about the blue line. Now, again, for the blue line, this is the my support vector from the triangle because that is the nearest entity from the blue line in the triangles. And for the circles, this is the nearest entity. So I will call this as support vector, this as a support vector. And then I will plot the parallel line. Now the distance between them, as in this line and the blue line I'm calling as K1, and the distance between this line, which I have plotted parallel to the hyperplane, touching the nearest circle to that line, I will call it as K2. The sum of K1 and K2 I will call as margin. Similarly, we already did this D1 plus D2. Now I will choose that model or that line as the final line to separate the triangle or the circle is the one where the summation of D1 plus D2 or K1 plus K2, which is margin, is going to be the highest. So higher the margin, better it is for the support vector machine, or that would be the answer of the support vector machine algorithm, and that would be my hyperplane. So if d1 plus d2 is coming as, say, I'm just taking the number, say 5 meter, and this is coming as 4 meter, this would be my final model, and the equation of this line is my hyperplane. So what will happen that if I get a new data, suppose I get a new data falls in this region, I will categorize it as circle, and if it fall in this region, I will categorize it as a triangle. Okay. Now, higher the margin, better it is for uh, the support vector machine model. So that's what I tried to explain, that higher the margin, better is the difference between the two different class. But what if the new data fall in this region? Now this lead to error, because this is a reason of misclassification, right? If the data fall in the margin region, it is quite difficult to predict whether it will fall in the category or the class of a triangle or a circle. Now we have taken the example of triangle or circle, but you can say the triangle is the category of people who are defaulting, and circle is the category of people who are non-defaulting. So you can use this model to any different classification problem. Okay, so we completed the support vector machine. Now let's jump into k nearest neighbor. However, there is a very small point that is left. Now support vector machine that we discuss right now is or can be used for linear classification or linear classification problem. Now, if you have a problem where you have triangles, 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 and then you have circle like this, you will not be able to plot a straight line, right? So for that, you need the answer in the terms of higher dimensions equations, and therefore it cannot be solved directly by support vector machine. You need other algorithm. Okay, so if you can solve it linearly with the linear equations as a linear line equation or linear plane equation, you can use support vector machine. But if the data is such that it cannot be solved with the help of plane or a line equation, then you need to follow other model. Okay, coming back to k nearest neighbor. Now, very similar to support vector machine, if you get a new data, you need to classify that data, that new data, whether it is triangle or a circle, or whether the new data is default or non-defaulting. So we'll take an example of triangle and circle, and we'll try to understand with the help of a triangle and circle, and we'll use the same logic for finding whether the person will default or not default, win or lose. So assume there are some feature x1 and x2, and based on that feature you plotted the data point. This is the first data point, second data point, third, fourth, so and so forth. You plotted the different data point. Now x1 could be one feature like revenue, or x2 could be another feature like COGS. If it is not company, and if you're talking about person, then x1 could be age of the person, and x2 could be, say, the salary of the person. Okay, and you plotted the different data point. Now, so the circle and the triangles are the different data points. This point is a new data, and you want to categorize this point, this new point. This is a new point. This is not a circle. This is a new point, new data point, and you want to categorize it either as a triangle or a circle. So you are following a algorithm that is called as k nearest neighbor. What you'll do, you will try to find out the distance between all the data point from this point. For that, and after that, you have to specify your k. K is again a hyperparameter for kernel, which has to be specified from the developer, from the researcher, from the model owner. Now, k could be 3, k could be 5, k could be 7, but it has to be odd number. It cannot be even number. Why not? We'll understand. So, you find the distance. Now, this distance could be Euclidean distance, right? We already know how to calculate the Euclidean distance. So, this is the formula to find out the Euclidean distance between the two data points. So you're trying to find out the distance between these two data points, these two data points, these two data points. And when you look at your k, which right now is 3, you have to look into the nearest 3 data point. So the first nearest data point was a triangle. Okay, the second was also the triangle, and the third was the circle. This circle, not this one. This circle was the third nearest one. So in 3 selection, how you got the number 3? It could be 5 also. But right now it is 3 because that is given by the model. That is the hyperparameter. That was given by the modeler, the model owner, the researcher. So now if you vote, triangle is winning the game, and therefore at last you will categorize this new data point as triangle. Now if the scenario would have been like, you have taken the k as 5, and the first is triangle, the second is triangle, the third is circle, the fourth is circle, and the fifth is also circle, then you can understand the vote. If you see it as a vote, then who's winning the game? It's the circle. So you will categorize this data point as a circle. So that is the k nearest neighbor. Okay. Now, why it cannot be even? For example, you take k as 2, then first data point came as circle, nearest to the circle, and the second came nearest to the triangle. Now you cannot decide whether it is a triangle or a circle, because the first two data point, nearest data point, the first two nearest data point are triangle and a circle. So you cannot decide. Therefore, it is necessary that this k that you decide, which is a hyperparameter, has to be a odd number. It cannot be an even number. So that is k nearest neighbor. Now let's understand the ensembled learning. Now there is one single model. You provide some input and it will throw some output. But this is one model. It could be SVM, it could be linear regression, it could be KNN. But this is one model. It could be either SVM or KNN or logistic regression or lasso regression. But what if you want to use all the different models? Okay, so I want to use SVM, I want to use KNN, I want to use logistic regression, I want to use normal regression, I want to use lasso regression. So these are the different models, and I call these model as a base learner or my classifiers. Now this is my training data. So the training data will train this SVM model and will throw certain result. Again, this training data will run on KNN and it will throw some result. Again, the training data will run on logistic regression, it will throw some results, so on and so forth. Now assume that SVM is throwing a result of default, KNN is throwing a result of default, logistic is throwing a result of non-default, and regression is throwing a result of default, and lasso is throwing the result of non-default. Again, you will do the voting, and the resultant classifier is decided based on the vote. So the highest number of vote right now is being in the favor of what? Default. So the result would be default. So ensemble learning, what is the beauty of ensemble learning? That you would be using a lot of models. So the error because of SVM will get reduced due to KNN, and the error because of SVM and KNN combined will get reduced due to logistic regression and then regression. So this resultant classifier is very powerful than this single classifier. But understand, all these classifiers are heterogeneous in nature. You're not using the SVM model in all the different base learner, all the different classifier. But You can do that also. You can use SVM, 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 SVM as all the different models, all the different classifier or the different base learner, right? Now, this is called as homogeneous classifier. Everything is similar. The only thing will change that you will not give the complete training data set to one of the SVM model or the first classifier. You will do the bootstrapping. You will randomly select the training data. From the training data, you will randomly select the first training set, give it to the first SVM model. Then you select the second training set from the training data, the original training data, and then you give it to the second, then third, then fourth, and then fifth. So basically what you're doing, you're bootstrapping your training data. I will understand what is a bootstrapping method. Bootstrapping method, in a very simple term, you randomly select a pre-specified pre-specified set of numbers of data point from your data. That's the bootstrapping. So assume you have say 100 data points. So you can randomly select say 20 data point. Again, you can randomly select the 20 data point, and it is quite possible that some of the data points can be duplicate. So that is the bootstrapping method. Okay. Into the bootstrapping when we'll enter into the random forest. Now, before entering into random forest, we also need to understand something called as decision tree. Okay, so you can see there are certain data that we have. We have age of a person, we have job status of the person, we have the information whether the person owns the house or not, what is the credit rating, and then you have to classify whether you will provide or lend loan to that person. Okay, it could be yes, it could be no. Okay, now there could be different types of decision tree. One of the decision tree is, okay, if the age is categorized as yes, then I will check for the job status. If the job status is there as yes, as in he has a job, then I will give the person loan. However, if the person is say old, I will check for what credit rating. If the credit rating is fair, I will not give the loan. If it is good, then I will give the loan, and if it is excellent, then definitely I will give the loan. If the person is of middle age, then I will check whether the person will have house. So such kind of a decision tree you can create. This is one of the decision tree. A decision tree could be more complex or more simple. A simple one look like, you will check whether the person have house or own a house for collateral or not. If yes, then you will give the loan. If not, you will check for job. If it is yes, you will give the loan. So the decision tree could be very simple. Now the first node is called as root node, and it is quite important concept because there is a proper mathematical logic to find the root node. Okay, so there is a complete math behind it, but that's not in our curriculum. So what I'm trying to say, the decision tree could be very simple, could be very complex. However, we can also create a very complex decision tree with the existing decision tree. For example, here I want to add a variable, say job status again. So if the person does not own the house, now I will check for what? Job status. And if I'll check for the job status, and if it is true, then I will give the person loan. So the answer is yes. Okay. It could go further down. So if the person doesn't have house, then it will check for other decisions node, right? And then it will answer yes or no. So the decision tree, it is a very simple plain vanilla technique to answer whether a particular new entity will fall as yes or no, as a defaulter or a non-defaulter. Okay. The only thing that you should take from this slide is that multiple different decision tree can be created, and it is not easy to find out the root nodes, and there is a proper logical explanation, mathematical explanation, lengthy explanation to find your root node. which would be the determining factor, the most important factor in determining whether you should classify something as A or B. Okay, moving to random forest. Random forest is a combination of ensemble learning, bootstrapping, and decision tree. What was ensemble learning? Ensemble learning was a learning where you use not only one model but multiple model, right? So you do not rely only on one model but multiple models. So that was ensemble learning. What is bootstrapping? You randomly select the data from the original data. And what is decision tree? We just learned what is decision tree. Okay, so assume that this is my original data. So I will bootstrap my data. I randomly select few IDs. Say I selected ID number 2. There are multiple ID from 1, 2, 3, 4, 5, 6, 7 till 15. We have different IDs. So I have selected 2, 5, 7, and 10. I will have age, job status, house owner or not, credit rating. And then I will create what? A given decision tree. The decision tree start from age, then check for the whether the person has house or not. If the person is young, yes, I will give the loan. If old, then I will check for house, whether the person is owner for the house and the house can be kept as a collateral. If yes, then definitely the answer is yes, you will give the loan. So this is your decision tree one. Now then again you bootstrap. What is the meaning of bootstrap? You randomly select say 3 data point, then you create a decision tree. Now this decision tree is a very simple decision tree. Own the house, job status, that's it. So if the person own the house, okay, give the loan. If not, check for the job status. If yes, give the loan. Okay. Then again you bootstrap your data. Now here in bootstrapping, you should understand the data point could be 4, 5, 4, 4, 5, 5. So what I'm trying to say in bootstrapping, a particular ID or the particular data point can be repeated. Now you created this decision tree. Now what you will do in the random forest, you will now apply ensemble learning. Now assume you get a new data. So what you will do, you will run this new data from the first decision tree. Assume the answer is yes. Then you run the data from the second decision tree. Assume the answer is yes. And then you run the data from the third decision tree and the answer is no. Now you will vote. And we know yes is winning the vote. So therefore at the end what you will do, you will say yes to the person, you will lend the loan to the person. Okay. That's what is the random forest. Okay, this is what we have to understand in supervised learning. Now we'll enter into the discussion of unsupervised learning and different algorithms in unsupervised learning.